0317 hours. The Strait of Hormuz. The SPY-6 radar aboard the USS Gerald R. Ford completes a routine sweep of the northern approach corridor and finds nothing. Then it sweeps again. This time, at the edge of detection range, a single return appears. Small, low, moving fast at wave-top altitude. Before the watch operator can classify it, a second return materializes. Then a third. Then 7 more in rapid succession. Within 40 seconds, the tactical display has transformed from a clean green field into a cascading storm of red symbols that keeps growing. 31, 38, 44, 52 contacts, all inbound, all moving at speeds between 400 and 700 miles per hour, all converging on a single point at the center of the formation, the carrier. This is not a probe. This is not a demonstration. This is the full weight of 3 months of covert preparation, modified commercial drones carrying 40-kilogram warheads, Iranian-supplied Quds, 1 cruise missiles, and second-generation suicide drones, whose guidance software was rebuilt from the ground up specifically to defeat GPS-dependent intercept solutions. 52 simultaneous targets in a 94-second engagement window against a $13 billion warship with 5,000 sailors aboard. The clock starts now. 840,000 barrels of oil flow through this strait every single hour. That number does not belong to the energy markets alone. It belongs to grocery prices in Ohio, heating costs in Germany, and manufacturing margins in South Korea. If a single weapon in that incoming swarm reaches its mark, the economic damage to the global supply chain will register within hours, not days. The Houthi commanders who planned this operation understood that. They did not plan to win a naval battle. They planned to win an economic one. Sink or cripple the Ford in the world's most watched energy choke point. And the message writes itself. The U.S. Navy cannot protect the Strait of Hormuz, and anything that cannot be protected will be priced accordingly by every market that depends on it. The plan is intelligent. The execution is disciplined. And it is built on one assumption that is about to prove catastrophically wrong. The assumption is that the U.S. is seeing the same picture the Houthis are seeing. That the swarm of 52 contacts screaming across the strait's surface is what the Ford's Combat Information Center is trying to process. That the sensor picture is as chaotic from the American side as the Houthis designed it to be. The modified commercial drones are hugging the hulls of oil tankers in the southbound shipping lane, bleeding their radar returns into the massive steel signatures of vessels 300 meters long. The GPS spoofing transmitters that the Houthi technical teams installed on 3 separate coastal sites 4 weeks ago are pulsing interference signals that generate hundreds of ghost contacts for every real target. The Aegis display should be a hall of mirrors, a nightmare of ambiguous tracks that turns a fire control decision into a political liability. Engage aggressively and risk hitting a neutral tanker. Engage conservatively and let the genuine threats through. This is what the Houthis planned for. They did not plan for what was watching from above it. The E-2D Advanced Hawkeye that has been orbiting at 26,000 feet since before the first target appeared is not looking at the surface picture. It is looking at the sky above the surface picture. And at this altitude, its AN/APS-145 radar has a geometry advantage that the Houthi GPS spoofing transmitters cannot affect. The spoofing signals generate ghost contacts on surface-level radar returns. They do not generate the infrared signatures that the F-35C aircraft orbiting at the edge of the strait's airspace are passively recording through their distributed aperture systems. An $8,000 modified commercial drone with a 40-kilogram warhead has a thermal signature. A ghost contact generated by a spoofing transmitter does not. The F-35C's DAS is not looking for radar returns. It is looking for heat. And every real target in that swarm is generating heat from its engine at a frequency that no electronic spoofing system can fabricate. The data flows from the F-35Cs through the encrypted Link 16 network into the Hawkeye's mission computers, which fuse it against the radar picture and begin the filtering process. The Aegis system aboard the Ford receives the fused output. What was a hall of mirrors is now a prioritized targeting solution. The ghost contacts collapse out of the picture as the AI cross-references radar returns against infrared signatures. What remains is 52 confirmed real targets, categorized by speed, altitude, weapon load probability, and time to the Ford's defensive perimeter. The Houthis designed their attack to overwhelm the Ford's sensor picture. The kill web stripped the deception layer in 11 seconds, 322 hours. The Ford's portside vertical launch system covers blow open in a sequence of synchronized detonations. RIM 162 evolved Sea Sparrow missiles launch in ripple fire, their solid rocket boosters lighting the strait for miles in every direction. Simultaneously, the escort destroyers flanking the formation, the USS Bainbridge to port, the USS Cole to starboard, begin their own intercept sequences, each ship processing the distributed targeting picture from the Hawkeye and assigning weapons to targets that the other ships are not already engaging. This is the cooperative engagement capability operating as designed, a single integrated weapon system spread across multiple hulls, eliminating the duplication that would otherwise exhaust the magazine depth of any individual ship. The ESSM rounds handle the outer wave. 29 contacts disappear from the tactical display in a window of 40 seconds. The sky above the strait strobes with intercept detonations. The Houthi operators watching their drone feeds see their first wave simply stop transmitting, one after another, as if a switch is being thrown down a line of streetlights. The second wave is the designed response to exactly this defensive pattern. The Houthi planning team is not amateur. They studied the U.S. Navy's intercept doctrine, specifically the tendency of layered air defense to focus magazine depth on the primary inbound axis. And they built a second attack layer that activates when the first wave is destroyed. 23 remaining contacts simultaneously drop altitude to 15 feet above the wave surface and accelerate, using the sea state clutter created by the saltwater spray at the strait's surface to complicate the radar tracking geometry for the next intercept layer. This is a real tactic, not a gesture. At 15 feet of altitude in a moderate sea state, a subsonic target becomes significantly harder to maintain a continuous fire control track on, and the Ford has been expending its outer ring intercept capacity on the first wave for the past 40 seconds. At 0328 hours, the Houthis execute the move they believe changes the geometry of the engagement in their favor. Shore-based high-power emitters located in coastal positions north of the strait activate simultaneously and drive a wall of broadband electronic interference across every frequency band the Ford's remaining intercept systems use. The Aegis display does not flicker. It whiteouts. The SPY-6 radar is still physically spinning, and the electronics are still functionally operational, but the receiver chain is saturated. The screen shows nothing but uniform noise. 18 remaining targets are inside the defensive perimeter, and the Ford is, for the first time in this engagement, genuinely blind. The Houthi operators at the shore emitter stations believe the engagement has just shifted. They are correct that the Ford's primary radar is saturated. They do not know that the EA-18G Growler that has been orbiting in silent standby since before the engagement began has been waiting for exactly this moment. The EA-18G Growler is the most capable electronic warfare aircraft on Earth. What it does is not jamming in the traditional sense. The AN/ALQ-99 Next Generation Jammer identifies the precise emission frequency of each shore-based transmitter and returns a signal that is not noise but a precisely engineered waveform designed to saturate the craft transmitter's own amplifier chain. The effect is not interference, it is inversion. The shore emitters that attempted to blind the Ford instead find their own output being used against them. Their signal strength consumed by a counter waveform that collapses their effective radiated power to zero in under 3 seconds. The wall of interference falls silent. The Ford's radar picture clears. The Growler did not put noise-canceling headphones on the fleet. It turned the enemy's speakers off. The F-35C distributed aperture system never lost the targets. The infrared tracking picture was continuous through the electronic warfare window because infrared does not care about radar interference. The Ford's fire control system transitions from primary radar guidance to F-35C infrared handoff in 1.4 seconds, and the remaining 18 targets are still lit in the tactical picture, every one of them, exactly where the geometry says they should be. But 18 targets at sea-skimming altitude inside 12 miles is a different problem than 18 targets at altitude outside 30 miles. The engagement geometry has shifted from the outer intercept layer to the inner one. And here the calculus changes, because at these ranges and altitudes, the ESSM has limited engagement time, and the Ford's Phalanx close-in weapon system becomes the last physical barrier between the warhead and the hull. There is also something under the water. The two Ghadir-class miniature submarines that the Houthi technical teams deployed from a support vessel 3 days ago have been lying on the strait's bottom at 40 meters depth since 0100 hours, waiting for the acoustic signature of the Ford's defensive engagement to reach maximum intensity. The acoustic environment around an active carrier strike group under air attack is the loudest maritime environment that exists. And in that noise, a Ghadir-class submarine running on battery power at 3 knots is genuinely difficult to distinguish from background. The Houthis planned the underwater component specifically to exploit this window. Their calculation: during the peak of the aerial engagement, slip into firing range under the acoustic cover of the battle above, and deliver the blow from the one vector the carrier crew is not watching. They had no idea the USS Hawaii was already there. The Virginia-class fast attack submarine had been sitting in the deep acoustic channel off the Bez Strait's northern shelf for 48 hours, running at ambient temperature with every active system in standby. Its ANBQQ-10 passive sonar array had been tracking both Ghadir contacts since they deployed from the support vessel on day 1. Not approximately, precisely. The Hawaii knew their battery charge rates, their propulsion profiles, their depth adjustments as they settled into position. When the aerial engagement began and the Ghadir crews activated their propulsion to begin their approach, the Hawaii's sonar room registered the increase in acoustic output against the background noise floor and confirmed firing solutions that had been continuously updated for 48 hours. Both Mark 48 ADCAP torpedoes were in the water before either Ghadir crew completed their attack approach. Neither submarine reached firing range. Back above the surface, the 18 sea-skimming targets are inside 8 miles. The inner defense layer activates. Rolling airframe missiles from the Ford's close-in launcher engage the approaching contacts in the 6 to 4 mile band, their infrared seekers following the thermal signatures. The F-35Cs have been tracking continuously through the electronic warfare window. 5 contacts are destroyed in this layer. The remaining 13 have now compressed into the Phalanx engagement zone. The Phalanx Block 1B close-in weapon system is not a weapon in the sense that most weapons are described. It is an automated system that operates on its own targeting logic, its own radar, and its own firing decision timeline without requiring human authorization, because at this range and this closure rate, there is no human decision cycle that closes fast enough. It fires 20mm depleted uranium rounds at 4,500 rounds per minute. Each burst is calculated by the system's own processor against the target's flight path, and the density of the outgoing round stream creates a wall of kinetic energy in the target's flight path rather than relying on a single aimed shot. Against a target moving at 700 miles per hour at 15 feet of altitude, this is the correct solution. Against 13 simultaneous targets, it is the most demanding scenario the system has been tested against outside of wargame simulation. 12 of the 13 contacts are destroyed in the Phalanx engagement zone. The 13th, a Quds, one cruise missile whose aerodynamic characteristics gave it a slightly different terminal ballistic response than the Phalanx firing solution predicted, takes 5 rounds through its warhead before inertia carries the disintegrating airframe through the final burst and into the Ford's outer hull above the waterline. The warhead does not fully detonate. The fuse initiates, but the shaped charge pattern that would have concentrated the blast inward fires partially, delivering an overpressure event and a spray of casing fragments rather than the penetrating detonation the weapon was designed to produce. A fire erupts in a compartment adjacent to the impact point. A deck crew member takes fragment injuries. The Ford's damage control team contains the fire in 11 minutes. The hull is intact. The propulsion plant is operational. The flight deck never stopped functioning. The total engagement ran from first detection to last intercept in 16 minutes. During those 16 minutes, the Ford-launched aircraft managed a 52-target aerial intercept sequence, neutralized an underwater threat it was not officially tracking, survived an electronic warfare blackout window, absorbed a partial warhead detonation, and controlled a hull fire. The flight operations log shows no gap in the launch and recovery cycle. The tactical action officer logged the engagement, noted the hull damage, flagged the injured crew member for medical follow-up, and resumed standard patrol posture. In the Houthi Operations Center in Yemen, the feed from the Coastal Observation Network showed what every engagement the U.S. Navy has ever had with this threat type eventually shows. The carrier is still moving. It did not slow. It did not change course. The smoke that briefly marked the impact point was gone within the hour. The cost accounting of the engagement is precise and telling. The Houthis expended an estimated $11 million in drone and missile inventory to execute a 52-weapon attack that required 3 months of preparation and drew on Iranian technical support, GPS spoofing infrastructure, shore-based jamming systems, and a covert submarine deployment. The U.S. Navy expended approximately $38 million in interceptor ordnance, Growler sortie costs, and Mark 48 torpedoes. The exchange ratio favors the defender. But the more important number is the strategic outcome. The Ford completed its transit of the Strait of Hormuz on schedule. The 840,000 barrels of oil per hour that flow through that waterway continued to flow. The economic disruption the Houthis designed this attack to produce did not occur, because the ship the attack was designed to stop never stopped. The lesson the Houthi technical teams will draw from this engagement is the same lesson every adversary draws from a failed saturation attack against an integrated carrier. Defense. The failure was not in the weapons. The weapons performed to specification. The failure was in the model of what they were attacking. The Houthis built their operation against a single ship with a layered point defense. They attacked an information architecture that connects every sensor in the formation and processes the entire threat picture faster than any human decision cycle they have. The 52 weapons in the swarm were not racing against the Ford's missile inventory. They were racing against an algorithm that had classified and assigned intercept solutions to all 52 of them before the outer defensive layer fired its first round. The GPS spoofing that was supposed to turn the Aegis picture into a hall of mirrors was countered by infrared sensors that do not use GPS. The electronic warfare blackout that was supposed to blind the terminal defense was countered by a jammer that had been sitting silent specifically to wait for it. The submarine that was supposed to deliver the blow from the unguarded vector was tracked from its deployment point 3 days before the attack began. The Houthis built a trap. Every layer of it was already accounted for before the engagement began. The partial warhead impact that scarred the Ford's hull is the detail that every adversary will study in the post-engagement analysis. Not because it represents a strategic success, it does not, but because it represents the closest the attack came to its objective. And understanding how it got through tells the next iteration of this threat what needs to improve. The U.S. Navy will study the same data with the same purpose. The phalanx firing solution that produced a 12 of 13 intercept rate against sea-skimming targets in that terminal geometry will be updated. The algorithm that predicted the Quds, one's terminal ballistic response, was off by a margin that allowed 1 round through. That margin will be closed before the next engagement. The Ford sails on. The strait is open. The oil is moving. And somewhere in the data archives of the Pacific Fleet's Intelligence Center, the electromagnetic signatures produced by every Houthi technical system that activated during this engagement are being cataloged against future threat profiles. The swarm that was supposed to create a strategic crisis instead created a targeting database. If you want to understand how the KillWeb sensor fusion architecture actually handles a multi-domain simultaneous attack of play, this complexity, subscribe. We break down the real system architecture, not the simplified version. And tell me in the comments, if the Houthis had timed the underwater attack to arrive 30 seconds before the aerial swarm, instead of simultaneously with it, does the Ford's response hold? Think through what that sequence change does to the acoustic environment the Hawaii was listening in before you answer. The scenario described in this video is a technical and tactical analysis based on real military assets, published defense specifications, and documented regional tensions. The specific engagement sequences are hypothetical dramatizations created to illustrate U.S. Navy Integrated Carrier Strike Group defensive doctrine and kill web architecture.